So now we know what a relational database looks like, we're going to think about how we retrieve information from the database. So assuming that you've gone through the whole process of designing an ERD from your ontology, you've gone through the mapping your ERD to the table structure, your schema, and let's say that, poof, you went through and actually implemented a database in a relational database management system like Oracle or MySQL or SQLite, and poof, magically and miraculously you got data into the database through some kind of a program or some kind of a bulk load or whatever it is. Right now, let's not worry about that, that part of the database work. So let's not worry about how we actually start the database, how we actually get data into the database, how we actually connect to it, how we actually run the queries. That's going to be something we're going to worry about next week, where we're going to study SQLite as an example of a relational database management system. And then I'm going to show you how to execute SQL from the so-called query console, which is very common, and also how to create a new database. And I'm going to show you how to add data to tables in the database. But for now, kind of assume that has happened. Assume simply that the database is there, that you have a database you created that contains tables, and what you really want to do is you want to query the database with SQL. You want to get back some results. Similar to what you've done with XPath. So if you want to go and do the equivalent here, so basically the equivalent for us here for SQL is XPath. What we had here before was an XML document. And we needed some other system to kind of do this. And we used Freeformatter as our query engine. Well, here we're going to use SQLite. Except we haven't gotten to this part yet. So let's assume we've built a database and we got a database with a simple table. Let me go and set one up for you. We'll use that same patient database that we've seen before. Let's start simple. Single table, very simple database, no second table, just a single table in the database. Almost never happens, but let's pretend that it does. And we only have 3 columns per patient record, the ID of the patient, the name of the patient, and the primary key physician for the patient. And we only have the primary key physician's name. Going to keep it very simple. So how would you query that database, assuming that you have some kind of a query console, a query program, which we're going to talk about later on. So right now, just assume that we have it. How would you actually express a query against a relational database? Well, the way you do this is that you build what we call SQL statements. More precisely, SQL SELECT statements. Now, to understand SQL, it makes sense to understand the 3 primary query types or retrieval types of a relational database, and they are called selection, projection, and join. Now, selection means that you try to come up with certain rows that meet your criteria. Find all the patients whose primary care physician is Dr. Jane. It would be this one, this one, and this one. I'm selecting 3 rows. It's called a selection. Projection means that we select certain columns. Find me the names of the patients whose primary care physician is Dr. Jane, which means you only care about the name column, not any other column. And then join is you combine data in multiple tables. Right now, that's non-issue for us because we really don't have multiple tables. So we're not going to worry about this one right here. All right? We're just going to worry about selection and projection. So the way you do this is you run a query statement. And the query statement is called select. So this keyword that we use for that is select. Select means that you want to retrieve or select certain rows from a table or maybe certain columns. So the first thing you do is you provide your projection clause. You basically specify the columns that you want. Then you specify the tables from which you want it, basically the tables from which you want to retrieve the data. And then you specify a where clause where you specify the rows or the selection criteria that you want. So this is basically your selection, right? And then if you had multiples, you would put your join right here. So let's do an example. We need to find all the patients whose primary care physician is Dr. Chain. So how do we do this? Well, we do a select. Now we want all the columns, so we just say star. So there's no particular projection. From, now we have to know in our database which table contains the information we're looking for. Well, we only have one table, so it's the patient's table. So from patient, where, and we only want to find those rows where the primary column value is equal to Dr. Jane. So this is the column we're looking for here. You want to make it a habit of putting a semicolon at the end of all your select statements because a lot of the consoles require that. So that kind of is just good habit. So that is finding the patients whose primary physician is Dr. Jane. Now, if you want to revise this a little bit and say, well, find the names of the patients. In other words, we don't want all the other information. We just want the names. Then we would replace this with name, because we only care about the name column, not any other column. Now, if we wanted to find the names of all the patients, regardless who the primary care physician is, I would do the same thing, except this time around, I would not specify a where clause. If I leave the where clause out, I'm leaving the where clause unspecified and say, well, there is no criteria. Just simply find me the names of all patients. Select the name column from the patient table. So that basically is a pure projection without an accompanying selection. So now we know how to retrieve data from a single table using a where clause. Now, of course, we can get a bit more fancy. If we had multiple clauses, we can combine it with and. For example, we can say where the name is equal to Dr. Jane, or the name is equal to Dr. Wu. So we would only get those whose primary care physician is Dr. Jane or Dr. Wu, but Dr. Meyer, well, would not get Dr. Meyer because it would not be named here. Or you could have a where clause that says where the name is equal to Dr. Jane and, oh, sorry, not name. I'm doing this wrong here. Sorry, by the way, it's primary. The column is primary. Hopefully I didn't make the same mistake before, but the column is primary for the primary care physician. And the name is equal to Anne. So I'm going to find all the patients whose name is Anne and the primary care physician is Dr. Jane. So if there is an Anne that's with Dr. Wu, I would not find that. So that's what we call a compound query, where I have two different query selection mechanisms. All right, so hopefully that makes a little bit of sense. It's a relatively straightforward way of doing this, but notice that the entire axis is based on tables, which is different than XPath, because XPath was built on the idea of a tree, and you navigate a tree. You find all the elements that are somewhere in the tree that specify or have certain criteria that they meet. Whereas here, you're looking for all the records or elements that are in certain tables that specify certain criteria. So there is a little bit of a similarity between XPath and SQL, but they work on different types of data structures, a tree structure versus a tabular structure. So when we get into more complex SQL, we're going to start worrying about how we actually combine information from multiple tables and how we deal with it. By the way, I want to show you just one more thing. There's one more interesting you can add to it. You can add an order by clause, and then you can order by a certain column. For example, you can say select name from patient. Let me just erase this here so we can put this down at the bottom. I'm going to show you how that works. It's very similar to the sorting mechanism that we saw in SQL. You can say, not SQL, XML, so order by name. So this would basically now retrieve the names from the patients, all the names of all the patients from the patient table, ordered by name. By default, it's alphabetical sorting in descending order. So it starts with the A's, goes to the B's, goes to the C's, all the way to the Z's. Or you can actually specify the criteria by saying DESC for descending or ASC for ascending, although that's a default anyway. All right, so hopefully that gives you a little bit of an idea as to how it works and how you might express very, very simple queries in SQL. So the next step, of course, is to study really SQL in more detail. Think about more complex queries. Think about how you deal with duplicates, and particularly think about how you deal with information that is present in multiple tables.